I found an interesting circuit in the radio Constructor of 1967, the September issue, on page 110. You can find it via worldradiohistory.com, and it is about a micro power amplifier. And it is so interesting because I have to turn down the camera for a while. Sorry for all the movements. Micro power amplifier. I will zoom in a little bit. So it is so interesting because it can work on 1.5 volts. And the second thing is that it is made with silicon transistors, and that is in those days a little bit new. The other interesting thing is that it is directly coupled. The circuit is directly coupled. So I leave it a little bit in this way so that you can read it. He's talking about the difference between constructing amplifiers via germanium transistors and silicium transistors or silicon transistors. Here there is a description about, say, the typical germanium transistor amplifier, and here it is all about the direct coupling, and it means that you connect the second transistor directly via a wire to the collector resistor of the preceding transistor, and that is showed here. Of course, you can find the circuit on the World Wide Web, worldradiohistory.com. And here is the complete circuit. And of course, it's made with perhaps transistors that are no longer available. That's no problem. I'm more or less sure you can use the BC547B NPN Silicon transistor with an amplification factor in the order of 150 up to 300. And here you see this direct connection between the collector of this transistor here to the base of the second transistor. When you do that with a germanium transistor, it cannot work, or it will be very, very difficult to get it working. But the reason is, that's also explained in the article, that the germanium transistor has a low barrier voltage, say 0.2 volts or so, while the silicon transistor has a barrier voltage in the order of 0.7 volt. Perhaps sometimes even 0.8 or something in between there. So this is the circuit. I think it's very interesting. 1.5 volts. The author also tells that you can supply it with a somewhat higher voltage, but I think 1.5 volt is interesting because of the very tiny current that flows in the circuit. I will get somewhat closer. They also talk about that 600 kilo ohm resistor R5 here, and when you change it, you can change the amplification a little bit, or perhaps more fierce. Anyway, you can read the original article. That's my advice. You always see, or not always, but often see this way here of, say, coupling back the signal out of the end transistor back via a wire to the input of the first transistor, and that is back coupling. And there is a positive back coupling. That means that the circuit starts to oscillate. There's also another type of back coupling where it helps to get the whole circuit under control. And because we have here a wire in between all these transistors and not a coupling capacitor, it is necessary to keep that circuit very good under control, and that's done so that it doesn't start to oscillate or start to be unstable. And that's a reason why you find this resistor. In, say, older circuits of the 1960s, transistor circuits, you will often see that resistor. Well, what's more to tell? Here, more information. I think also other NPN transistors with a good amplification factor will work. There's kind of warning here. Perhaps the BC547 or other modern silicon transistors have a too high amplification factor. And that means that perhaps you have to do, say, experiments with this resistor and with this resistor. The value of them, to get that circuit under control. Perhaps in the 1960s, the more or less standard silicon transistor, small signal silicon transistors, that's what I mean, had an amplification factor in the order of 150, 180, perhaps 200. And modern transistors have a much higher current amplification factor. And especially when they are made in China. Here, the method of adapting the circuit to be used with higher voltages. And here, the best position for a gain control. That's of course also important. And also because perhaps modern transistors have a higher current gain, then it could be necessary to limit the gain of the circuit. And when the gain is too high, the circuit will start to oscillate. So perhaps this can also help for a gain control. I wanted to make it, but at the moment I'm focusing on other experiments and other things that I'm going to show on YouTube. So, this is the complete article. You can read it in the original magazine. You can read it via this video. Thanks for watching. Let's go back to that beautiful circuit. And I think it is very well thought out by the author. Pen over a little bit. And here the author, always very important. Thanks for watching again.